A warm greeting to everyone. I am Selvi, Assistant Professor, CSE Department, RMD Engineering College. The subject code is 22CS201 Data Structure, Theory Course with Laboratory Component, Second Semester, Unit 3, Tree Data Structure. Now we are going to see representation of your binary tree. So the parent node can have, if you consider, now we are going to see a array representation of tree. If it is a complete binary tree with n nodes, the depth will be the form of log n plus 1 and it's represent sequential, that is an array form. The index value will start from 1 to n. The parent of I, that is parent of each node, will be at the position of I by 2. If I it's at the root and it has no parent. And left child of I will be at the position of 2i and 2i must be less than or equal to n. If 2i is greater than n, then I has no left child. Right child of I is at position 2i plus 1 if 2i plus 1 is less than or equal to n. Or if it is greater than n, then I do not have a right child. This is an example. Here, this is an example of a skewed binary tree. A and it has a left child B and there is no right child, so that space will be empty. And then C and there is no right child, so that space will be empty. And then D and there will be empty space for the nodes which does not have a left or right childs. So that will be a lot of space will be wasted in a skewed binary tree. We can confirm, we will go for a complete binary tree. Each node will have the complete 2 nodes. So the arrangements will be start from A parent node, A, then B, C, D, E, F, G, H, and I. So as per the representation, we consider any node. For example, node E. So what's the position? If we consider node E, it's at the position 5. So the I equal to 5. I equal to 5. That is the parent node. So if you consider the parent node for this, I mean left child will be at the position 2i. So left child, if consider position I, that is 5. So parent of I will be at I by 2 and left child will be 2i and right child will be 2i plus 1. I equal to 5. So parent of I E node will be at the position I by 2. So I by 2. So I by 2 will be I by 2 will be 5 by 2 which is 2.5. We can say it's an approximate of, it can round it as 2 or 5. So here I'm using the 2, which is the position for B. If we consider left child, is at position 2I. So 2 into I is 5, 10. At position 10, you will be having the left child. For E, there is no left child. So if we consider any other node, so take node C, which is at position 3, that is I equal to 3. Left child is equal to 2 into I. So it will be 2 into 3 is equal to 6. So at 6th position is F. F is the left child. And next, right child. Into I plus 1. So it's equal to 7. So at position 7, you will be having the right child G. So this is how there will be a sequential. Sequential is the array representation of a binary tree. Next is linked list representation of a binary tree. Each node will have a node structure, data part, the value going to hold, and the left child and the right child. Left child and right child will have the data structure of your node structure, and it will be a pointer pointing to the next node in a tree. Binary tree traversal. There are 3 types of binary tree traversals: inorder, postorder, and preorder. Inorder, the rule is it will first visit the left child and then the corresponding parent node and then the right child. So if you take this tree structure, it's actually a infix corresponding infix which is converted into a preorder infix expressions tree. If you start from the root, we go for the left subtree. So from here, we travel here. And then, which is also have a left subtree, we go here. Travel here. From here. So, preorder, we will be traveling in order. It will be traveling the leftmost. So, A will be here. There is no value. So, you don't consider these leaf nodes. Here, there is no values. So, don't consider it. So, we go for the left subtree, A, and the corresponding root, and then right subtree. So, A, A, corresponding root B, and then right subtree B. And after visiting this left subtree, and then the corresponding right subtree will be, root will be star, and the corresponding right subtree will be C. We will be finishing this part, the left subtree for this asterisk, and then the corresponding root and the right subtree D. Similarly, we will be finishing the left subtree plus and the right subtree E. So this will be the in-order traversal. For pre-order traversal, we'll be visiting the left subtree. We will first visit the root and then left subtree and then right subtree. So in pre-order traversal, the leftmost node will be the root node. Now I'm going to do the pre-order traversal. Now, first I will visit the root node plus and then left subtree. So left subtree as a root node, so asterisk, and then corresponding root node asterisk, and the corresponding left subtree root division, and then left subtree A. So I am printed A, and then left subtree, that is I have printed root, left subtree, and then right subtree. Corresponding here I printed the root, left subtree also I printed, then corresponding right subtree. So the corresponding right subtree will be left, so I will be writing everything. Similarly, for post-order traversal, we will be visiting the left subtree, right subtree, and the last you will be visit the root. So for post-order traversal, first we'll be visiting the left subtree. So we'll be traveling from here. From here, we'll travel the corresponding left subtree. We will reach the last here, last node. So A, and then corresponding right subtree and their corresponding parent. And then left subtree. This will be the answer. Thank you.